Welcome to the Privacy Report. Today, we are taking a fascinating, maybe slightly paranoid, trip into the world of ultimate digital security. We're looking beyond your typical firewalls, beyond multi-factor authentication. We're diving into systems that are deliberately, totally cut off from the global network.
Yeah, we're talking about air-gapped systems. If you can picture a digital fortress where the ultimate defense isn't some complex code, but just empty space,
Yeah.
the absence of any physical connection, that's where we're headed.
Exactly. And our mission today is really to unpack the reality of this extreme isolation. We need to look at the huge security benefits, definitely, but also the critical friction they create in practice. And maybe most importantly, how even this level of physical separation can actually be breached. Because why would anyone choose this if it's so hard to maintain? Well, the alternative, a catastrophic breach, is just unacceptable for some.
It's a necessary extreme, really, for the world's most critical data. And, if you want more insights into the logistics and some of the fascinating details we'll cover, remember you can subscribe to our email newsletter over at theprivacyreport.net.
So let's start right at the beginning then. We hear this term air gap.
Yeah.
What's the fundamental difference between that and just having, a really good firewall?
Okay, yeah, that's the critical distinction we need to get clear up front. An air-gapped system is a network, or maybe just one computer, that is physically separated from all unsecured networks, like the internet, obviously.
Yeah.
Your firewall gives you logical separation. It segments things, tells certain data packets, nope, you can't cross here.
That's network segmentation.
Right. An air gap means the hardware itself is never, ever allowed to connect. The defense is physical absence. No wires, no signals.
Okay, that clarifies why it's considered so powerful. So this means zero digital connectivity. Like, absolutely none. No Wi-Fi radio on the machine, no Bluetooth. The Ethernet port isn't plugged into anything that touches the outside world. And definitely no cellular modems hidden away somewhere.
Correct. You're eliminating the remote attack surface completely.
Which dramatically reduces the risk of remote hacking.
Precisely. If let's say, a nation-state actor or some sophisticated hacking group can't establish remote communication with the machine, well, they can't exploit it using typical network methods. The risk of remote hacking, ransomware getting in that way, network denial of service attacks, it drops to almost zero.
Almost zero. Okay, that's a key qualifier we'll definitely need to circle back to, that terrifying thought. But first, let's look at the operational need. Who is actually using systems this extreme? It sounds incredibly inconvenient.
Oh, it is inconvenient. Massively so. But in certain fields, the risk just massively outweighs that inconvenience. The use cases are usually tied to systems where, if they got compromised, the result would be catastrophic. We're talking loss of life, national security issues, or even global financial stability.
Like military systems, right?
Yeah.
I remember reading about the U.S. Department of Defense's classified network, SIPRNet. That operates in highly isolated setups.
That's the classic example, yes. But also, think about critical infrastructure. Nuclear facilities, for instance. They heavily air-gap their industrial control systems, or ICS.
The systems managing the physical processes.
Exactly. The cooling system, safety controls, that kind of thing. Imagine exposing those directly to the internet. They'd become immediate targets for huge, disruptive state-level attacks.
Makes sense. And the financial sector, too. Not just for, storing money, but actually creating the keys that secure it.
Correct. Generating and managing cryptographic keys often happens on completely isolated systems because the integrity of those master keys is absolutely paramount. If a key generator gets compromised, well, the implications for encrypted data worldwide are just enormous. Air gaps provide what you might call security certainty, a trustworthy environment that keeps running even if the wider digital world is, on fire.
Okay, but that security certainty comes at a price. And not just money for hardware, I'm guessing. The friction, the operational drag must be immense. You've cut off the network, which is how everything works now. What's the biggest operational trade-off here?
It's operational velocity, speed. Everything slows right down. If you can't use the network, every single input or output has to be handled manually, physically. This means significant maintenance overhead, and it demands just absurd levels of protocol compliance from everyone involved.
So let's take a standard software patch. Normally, that's automatic, instant practically. In an air-gapped world, what does patching look like? Is it even possible?
Oh, it's possible, but it's like meticulous, slow-motion surgery. First, you need a trusted source for the patch. often verified physical media straight from the vendor. That media never goes directly into the air-gapped system. Never.
Yeah, it's too risky.
Exactly. Instead, it has to go into an intermediary machine, usually a non-networked clean room station. There, it gets meticulously scanned, multiple trusted antivirus systems, everything checked. Only then is it manually transferred onto another physical medium, maybe a highly verified, often single-use USB stick or a CD. And this whole process happens under strict chain of custody protocols. Everything logged.
Wow. So a single operating system patch could involve, what, 4 people,
Wow.
3 different machines, a documented paper trail, just to move one file from A to B securely?
That's about right. And every single piece of media, whether it's an update or actual data that needs to come out for analysis, has to go through that same rigorous process. It's all about preventing any malware from sneaking across that physical gap on a USB drive or something. And this is why you really have to assess your data sensitivity. If the data isn't absolutely critical, this cost and labor, it's just not worth it.
Okay, that leads us straight to the critical flaw, doesn't it? If the software is locked down and there's no network connection, where does the security challenge shift? It shifts entirely onto the humans involved.
It absolutely shifts to human error and physical breach vectors. We have to understand the air gap is a massive deterrent against remote attacks, but it's almost powerless against someone with physical access and maybe a moment of carelessness or malice.
And the definitive case study here, the one that really changed how people thought about these systems, that has to be Stuxnet.
Stuxnet proved it. Proved the physical gap is not impenetrable. That malware famously infiltrated Iranian nuclear enrichment facilities, heavily air-gapped facilities. How did it cross that barrier? Infected USB drives, carried in by personnel.
Someone just plugged in a USB stick they shouldn't have, or maybe a contractor's device brought it in.
Exactly. Could have been an accident, could have been a compromised device introduced during maintenance. We don't know for sure the exact vector in that case. But the point is, the human element fundamentally undermined that multi-million-dollar physical security barrier.
So this raises a really important question. Beyond just someone making a mistake with a USB drive, what else can bridge that physical distance? What about threats from the inside?
Insider threats are, well, they're the constant nightmare for these kinds of systems. It could be staff, could be contractors, intentionally inserting malicious devices, or maybe just intentionally violating those strict manual data transfer rules we talked about. This is why rigorous staff training isn't just a suggestion. It's probably the primary ongoing defense against the most common way these systems get breached.
Okay, but what about the really advanced stuff? The kind of attacks you see in movies. You sometimes hear whispers about electromagnetic leaks or even acoustic leaks. Is that just theory? Or can data actually leak across a room without any network connection?
Oh, they are absolutely real, and they represent a unique challenge for air gap defense. These are highly specialized attacks that leverage physics, essentially. Researchers have demonstrated techniques where malware on the air-gapped machine can modulate the CPU's workload.
Modulate the CPU load.
Yeah, make it work slightly harder than slightly less in a specific pattern. This creates subtle, high-frequency audible tones. These tones, maybe hidden by the normal noise of a server fan, can actually transmit small amounts of data across a room. A nearby listening device, maybe a smartphone that's not connected to the target network, could pick up those tones and decode the data.
Wow. So you're basically turning the computer's own operating noise into a secret communication channel. That's brilliant and terrifying at the same time.
It is. And similarly, you have attacks monitoring electromagnetic radiation. Every electronic component emits faint signals. If an attacker can get a sensitive receiver close enough, they might be able to interpret those signals to extract data. It's incredibly difficult, requires proximity, but it's not impossible. It's why true high-security air-gapped environments often involve physical security measures too, like Faraday cages to block EM signals or soundproofing. The digital isolation needs physical reinforcement.
So setting up one of these environments isn't just about yanking out the Ethernet cable then. It requires intense discipline right from the very first step. You mentioned verified hardware earlier. What does that mean in practice?
It means you have to select hardware components that provably have no wireless capabilities built in at all, no hidden Wi-Fi chips, no Bluetooth modules slipped onto the motherboard. The components themselves need to come from a trusted supply chain as much as possible. Then you install the operating system strictly offline, no internet connection during setup, and critically, you harden that software. You'd disable every single unused service, every network port, every feature that isn't absolutely essential for the machine's specific task. Minimize any local entry points an insider might try to exploit.
And that vigilance, that hardening, it never stops, does it?
Yeah.
You need constant internal auditing of logs, a meticulous documentation for every single media transfer, in or out, constant compliance check.
Exactly. It ensures the security isn't just a one-time setup thing, but a continuously maintained operational philosophy.
So if we try to synthesize all this,
Yeah.
air gapping isn't the same as network segmentation using firewalls and VLANs. That's logical separation. It's an absolute physical separation. It offers incredibly powerful protection, but it's not perfect. It's mainly for truly critical data.
That's a good summary. It fundamentally shifts the security burden away from software vulnerabilities, which are hard to eliminate entirely, towards supply chain integrity and human behavior, which are also incredibly hard challenges.
So what does this all mean for you, the listener? I think it shows that security is holistic. If you build an absolutely impenetrable wall in one place, the attackers, or even just accidents, will simply find the easiest remaining point of entry. Often that's the human element.
And that leads me to a sort of provocative thought maybe for you to ponder. Given how absolutely critical supply chain integrity is for these air gap systems, systems designed to protect against global compromise, how much trust can we really place in the specialized hardware we buy, even off-the-shelf components? If a microchip is compromised before it even gets installed in your secure facility, while your air gap was potentially defeated before you even switched it on.
That is the ultimate digital catch-22, isn't it? A really great point to end on. Thank you for joining us for this discussion today.
It was a pleasure.
If you enjoyed our conversation, please do take a moment to like and subscribe to the Privacy Report wherever you get your audio. It really helps others find the show.
And we also want to disclose that this episode was made with the assistance of AI.